Hello everybody, this is Mr. Strager, and welcome back to Big Ideas. We're talking today about Section 4.3. Section 4.3 requires you to feel pretty comfortable with Section 4.2 since we're going to be using a lot of the math and a lot of the strategies that we talked about then. So let's get to it. Section 4.3 is all about parallel and perpendicular lines. These are lines that we may have heard of before in previous grades, but they might not have been elaborated as much as we would like. So let's talk a little bit about them. Let's say I had the following red line on my sheet of paper. Its y-intercept is 0, and its slope is up 3 over 2, so it's 3/2. If I wanted to make a line that was parallel to it, the word parallel just means that they are going in the same direction, never getting any closer to each other or further away. In other words, they're two lines that will never intersect. So in order to make sure they never get closer or further away, they should stay the same distance away from each other. Let's say I put a dot here. I wanted to plot my next parallel line. If I made a line that looks like this, notice how these lines never get any closer or further away. Here, on my y-axis, they're 5 away. Here, at the next point, they're still 5 away. Heck, even if I go backwards, they're still 5 away. That's one way you can tell something is parallel, but big ideas won't accept, oh, they just look like they never get closer. There is also a mathematical way to determine if lines are parallel or not. I wonder if you can spot it. Can you spot what would be the exact same about these two lines? If you can't, maybe it'll help if I write out the equations. The equation of this line is, well, its y-intercept is 5, and its slope is up 3 over 2, so that would mean 3/2 x plus 5. And if I wrote out the equation of the red line, its y-intercept is 0, its slope is up 3 over 2, so its equation is y equals 3/2 x. What's the same about these two? Well, you'll see they actually have the same slope. Because they're going up the same amount and over the same amount, they're never going to cross each other, because they're following the same set of directions. That's the main key here. And I want you to write this down on page 108 of your notes. Where it says parallel lines, I want you to star this. Parallel lines have the same slope. This is crucial for today's lesson because you're going to be able to see some lines that you have to figure out if they're parallel or not, some points and equations where you have to figure out if they're parallel or not, and then use one parallel line to find yet another parallel line. So if you want to look up the formal definition of parallel lines and slopes, here you are. Two lines in the same plane that never intersect, just like we talked about. I want us to turn to page 109, and let's take a look at problem number 1. We're trying to figure out if any of these lines are parallel. Now, you might say, Mr. Strager, I know which ones are parallel and which ones aren't. Yeah, well, prove it. That's the tricky part, is actually proving that they're parallel. I can look at these and I can say, well, this one doesn't look like it's parallel with the others, but it's nothing if I can't mathematically show why that is. But remember how we said parallel lines have the same slopes. If we can figure out which of these lines have the same slope, we'll know which ones are parallel and which ones aren't. So here's what I'd like you to do. I'd like you to find the slope of line A, line B, and line C. I then want you to compare them to try to see if any of them are the parallel. Again, lines that have the same slope will be parallel. So I want you to pause the video here and try and see if you can do it. Did you get it? the left line, we have a slope of 3. The middle line is a slope of 4, and the right line is a slope of 4. So, instinctually, we know which of these are going to be parallel. By the way, for those of you who didn't quite catch how to find the slopes, there's 2 ways of doing it. The way we like to do when you have a graph is to count your rise and then your run and put it in a fraction. So 3 over 1 gives us 3. To write out our answer, here's what we're going to do. We're going to compare line A to line B using a special symbol that we haven't talked about yet. So let's take a look. Line A is the red, line B is the blue. Are these 2 parallel or not? If you want to say that 2 lines are parallel, you're going to use this symbol. It just looks like 2 vertical parallel lines. If you want to say something is not parallel, you cross a line through it, sort of like tally marks. Since A has a slope of 3 and B has a slope of 4, we say that they're not parallel. Not parallel. What about line B and line C? Well, the blue line and the green line have the same slope, so we say that they are parallel. But what about the last pair? We compared A to B, B to C. Don't forget that we also need to compare the first to the last. In other words, we're comparing line C to line A. Line C has a slope of 4, line A has a slope of 3, so these are also not parallel. We can do something similar with number 3. This time we don't have a graph to help us find the slopes, but remember, as long as we can find the slopes, we can figure out what's parallel and what isn't. I'm going to walk you through how to find the slope of line A just as a refresher, but I want you to also be able to try this out. If you know how to do it, try it out on your own. If not, follow along with me for part A, and then we'll pause. To find the slope when you don't have a graph, you need to use your slope formula. y2 minus y1 over x2 minus x1. Let's say that this point is point number 2, this point is point number 1. That means that y2 would be 2, y1 would be negative 1, x2 would be 2, x1 would be negative 4. So 2 minus negative 1 will give us 3, 2 minus negative 4 will give us 6. Our slope is 1/2. Use this method to try to find the other slopes. Pause the video here, see what you get. Did you get these slopes? For the blue line, the slope ended up being 2/5. For the green line, it ended up being 1/2. So just like before, we want to compare line A to line B to line C, and to cover all of our bases, line C to line A. So, as we take a look at line A to B, A's slope was 1/2, B's slope was 2/5. Since they're different, they're not parallel. B and C have different slopes as well, so those aren't parallel. But C and A both have a slope of 1/2, so those are parallel. Next up is problem number 5. And problem number 5 is going to be a little bit trickier. They don't give us any points now, they're giving us equations. And we somehow need to find the slope from these. Remember, in order to find the slope, all you need to do is put it in slope-intercept form. Then you just have to simplify and figure out what the slope is in front of your x. Let's take line B, for example. If I have 8y equals negative 6x plus 16, what can I do to put this in slope-intercept form? Well, I have to divide by 8 because in slope-intercept form, the y is by itself. But that also means I have to divide everything by 8. That'll give us y equals negative 6 divided by 8, we can rewrite as negative 3 divided by 4, x, and 16 divided by 8 is 2. We don't care about this plus 2, though. All we care about is that the slope, m, is negative 3/4. Try to find the slopes of the other 2 lines in a similar way, and come back in just a moment. Did you get them? Line A has a slope of negative 4/3, line B has a slope of negative 3/4, and line C has a slope of negative 3/4. So when you write out your answer, the key here is that lines B and C are parallel. Line A is not parallel with either of them. The last part for the parallel line section is down here, number 7. And this is where you have to use your thinking cap a little bit. It says, write an equation of the line that passes through the given point and is parallel to the given line. Let me give you an example of what that means. If we look back at our example of parallel lines, the problem would tell you, for instance, line blue, it would give you a point, let's say right over here, and it would ask you to find a line that's parallel to the blue line. We know how that would look on a graph, but it's very difficult when you just have numbers to deal with. So let's figure it out. Well, they don't give us a y-intercept, so it'll be very hard to use slope-intercept form. Instead, when we have a point that we're given, we like to use point-slope form, at least for right now. Don't worry, we'll have other methods later on in the unit. Y minus y1 equals mx minus x1. And for this to work, we need to know the y-coordinate of our point for y1, the x-coordinate of our point for x1, and a slope. Well, the first two parts are easy enough. The y-coordinate is negative 1, so y minus negative 1 is just y plus 1. I'm going to leave the slope blank for now. We have x minus x1. x1 is 3, because that's the x value of our point. But now we need to figure out what this dang slope is. Well, remember, if the line we're trying to figure out down here is parallel to this line it gives us, what's going to be the same between the two? The slope is going to be exactly the same. So even though we don't know what our line looks like, we know the slope is also going to be 1/3. That's our point-slope form equation. Can we simplify this into slope-intercept form? To do so, we want to get y by itself by subtracting 1 from both sides. So we have y equals 1/3, then the quantity x minus 3 minus 1. But we don't want to have our x in parentheses. We want to get rid of the parentheses. How can we do that? The trick is with distribution. Anytime you have a number outside of your parentheses, you can distribute that number into the parentheses, and it'll actually get rid of your parentheses. That'll give us y equals 1/3 times x is 1/3 x. 1/3 times negative 3, you can think of it as what's 1/3 of negative 3. 1/3 of negative 3 is negative 1. And our minus 1 is at the end. So, to finish off the problem, we just combine these two negative 1's, giving us y equals 1/3 x minus 2. And that's what you need to know how to do for the parallel line section. But there was another definition that we were given here. The other definition they told us about were perpendicular lines. So let me draw out an example of perpendicular lines. The key with perpendicular lines is this. A line is perpendicular to another line if, and only if, the intersection forms 4 right angles. By right angles, we mean a 90-degree angle. Let me give you an example of something that is perpendicular and something that is not perpendicular. Something that is perpendicular would be a line going like this through our red and blue. Notice how we can kind of draw out these little corners here on each of the intersections. Those are right angles. Anytime they make a perfect corner, you can draw it out as a right angle. This is a perpendicular line. Something that would not be a perpendicular line would be like if I drew something like this. Right? Yeah, they intersect, but it doesn't make 90-degree angles. I can't draw that sharp 90-degree corner. I've got a small angle, and I've got a big angle. So this is not perpendicular, it's just intersecting. Now, parallel lines have the same slope, but would it make sense for this green line to have, say, the same slope as our blue line, 3/2? Well, it wouldn't make sense. Our blue line is going in this direction positively. Our green line is going to be going in the negative direction. So you might be tempted to say, well, hold on a second, maybe it's just that you have to make your slope negative. But that's not right either. Actually, in reality, if I draw out the equation of this line, our y-intercept here, ooh, I made a really bad line here, so let me actually make a better y-intercept. Let's draw the line that goes through here. There we go. Now our y-intercept will be 5, so it'll be a little easier to track. So we're looking at the bottom green line here. What's the slope? Well, if I go down to right 3, I find my next point. So our slope is negative 2/3. What do you notice about these two numbers, 3/2 and negative 2/3? To go from 3/2 to negative 2/3, two things need to happen. We make our number negative, and we flip the fraction. This is what we call a negative reciprocal. And you have to do both. You have to make it negative, or if it's already negative, make it positive, and flip the number. Otherwise, you will not get the proper slope. So let's try a couple of these. What's the negative reciprocal of 1/7? Well, we make it negative, and we flip it. Instead of 1/7, it would be 7/1, which we know simplifies just to give us -7. Okay, what if I gave you this? Find the negative reciprocal of -5/4. Well, we would make it negative. Since it's already negative, making it negative would make it positive. Double negative rule, remember? And when we flip it, that'll give us positive 4/5. Let's try a tricky one. What if I was to give you the task of finding the negative reciprocal of -2? Well, we know we're going to make it positive since it's already negative, but how do we flip this? Any whole number can be written as a fraction over 1, so this becomes positive 1/2. Let's go back to our notes section on page 108 just to write down the most important thing for perpendicular lines. Again, if you want to see the full definition, they intersect to form right angles. But the key about perpendicular lines that I want you to write down is this. Perpendicular lines have negative reciprocal slopes. So all the stuff that we looked at for parallel lines, we can kind of apply to perpendicular lines too. The key is the slopes won't be the exact same. They'll be negative and flipped. So let's go to page 110, where we're going to do a couple of these practices that'll look very familiar to us. For instance, let's take a look at problem number 10. Problem number 10 asks us to find if any of these lines, whoops, it's a little blurry, there we go, are parallel or perpendicular. In order to do that, let's find the slopes of all of them. So I want you to find the slope of line A, B, and C. Then try to see if on your own you can find any that are parallel, meaning they're the same, or perpendicular, meaning they're negative reciprocals. Pause the video here and try it out. We should see that the three slopes we get are 3, -1/3, and 5/2. Well, none of these are parallel to each other, but let's see about perpendicular. In order to be perpendicular, the slopes need to be negative reciprocals. So for instance, what's the negative reciprocal of 3? Well, the negative reciprocal of 3 is negative, and then we flip 3 on its head to give us 1/3. Hold up! That's the exact same slope as line B. That means that line A and line B are perpendicular. The symbol for perpendicular looks like this. We say that line A, and to show perpendicularity, we have sort of this T intersection, line B. There is no symbol for not perpendicular, so if we were looking for line B and line C, for instance, we would say is not perpendicular to line B. You just have to write it out, unfortunately. There's no slash through or anything. Since we've done a lot of these types of problems before, I don't doubt that we would feel pretty comfortable doing these again, but for the interest of time, I want us to take a look at problem 15. We want to write the equation of the line that is passing through this point and is perpendicular to the given line. If you already know how to do this, go ahead and skip ahead, or try it out for yourself, which is much more preferred. If you don't know how to do this, let's double check. So, in point-slope form, we have to know a point and a slope. We know that the point is -2, 2. So, the 2 goes with y1, because that's our y value, and the -2 goes with x1, because that's our x value. We write it out as y minus 2 equals some value m times x plus 2. That value of m is going to be the negative reciprocal of 2/3. So we got to take 2/3, and we have to make it negative and flip it, giving us -3/2. So our slope of our new line is going to be -3/2. At this point, the problem proceeds as usual. Again, you can either get rid of this -2 first, or distribute. Let's just distribute this time for variety's sake. Doesn't matter which you do first. -3/2 times x is -3/2 x. -3/2 times 2, you could do it in your calculator, but it turns out it actually ends up very nice when you do it by hand. If you did it by hand, you would find that it's actually just -3, because the 2's cancel out. All we need to do now is get y by itself by adding 2 to both sides, and we know that -3 plus 2 is -1. And that's it. Thank you so much, everybody. I hope you have a fantastic rest of your day, and as always, I will see you next time.